When we divide by 4, we either get x equals 2 or x equals negative 2. So two different things that would make this true. So when I check that, 4 times 2 would give me the 8, and 4 times negative 2 would give me the negative 8. So it works. I actually want to do this one next, number 2. In problem number 2, I got to get rid of the plus 5 before I can get started. So you have to get your absolute value all by itself. So I'm going to start by getting rid of the plus 5. And I have absolute value of 1/2 x equals 2. Good morning. So that means that what's inside the absolute value might be 2 and it might be negative 2. So we rewrite it both ways. And when you rewrite it, you do not put the absolute value on it. So you have two possibilities. Either 1/2 x equals 2 or 1/2 x equals negative 2. Fractions can be tricky to deal with. So I want you to take a minute and see if you can figure out what the two answers for x are and see if your neighbor gets the same thing. All right, so I want to do divided by 1/2 on both sides. When you divide by 1/2 on your TI, you're going to need to put parentheses around that 1/2. Now doing multiply by 2 is fine. A lot of you did multiply by 2 and that works. I just want to show you how to do the dividing one. So you're going to go to 2 divided by, so I hit the divide key. And then to make the fraction 1/2, I'm going to put parentheses around my fraction, so that goes here. And the fraction 1/2 is 1 divided by 2. So this is 2 divided by 1/2. And you get 4. So this one is x equals 4. This is really exactly the same except that I have a negative, so I get x equals negative 4. There are two solutions. And you need them both. It's not like I can have this one or that one. You need both solutions. Okay. Number 1 says the absolute value of 2x equals negative 4. I want you to talk to the people in your group about what's different about this problem and any issues you see with this. The absolute value of 2x equals negative 4. When you have an absolute value isolated like this and it equals a negative, that's a problem because the absolute value is going to turn things positive. That is completely different from the idea that's what inside of the absolute value could be negative. Here we're saying what's inside the absolute value could be positive or negative. True, because the absolute value will turn it positive. But this number over here has got to be positive. Because absolute value makes everything positive. So absolute value equals a negative number, that doesn't make any sense. There's no number I can put in for x to make this true. So from the very start, we know there's no solutions. But let's say you just start solving it, just, you not thinking, you start solving the problem. So let's start solving the problem. We write 2x equals negative 4, 2x equals 4. And I divide by 2, and I get x equals negative 2, and x equals 2. So like I can do steps and I can get answers, but then the question is, do they make sense? So I'll substitute back in here. The absolute value of 2 times negative 2 is the absolute value of negative 4, which is 4. I didn't get negative 4, right? So that means this solution's no good. I'm going to check this one. Absolute value of 2 times 2 is the absolute value of 4, which is 4. Did not give me negative 2. So checking it, I can see that that didn't work either. So the answer to this is no solution. All right, I want you guys to try number 4. And before you try number 4, I want to warn you. In number 4, you have to get this absolute value by itself before you can get started. So we have to get rid of that minus 7 with a what? Plus 7. And then this is a times 6. How will we get rid of the times 6? divide by 6, okay? So do those steps first. Get the absolute value by itself. Then you can write it twice. All right. So to get rid of the minus 7, you added 7. I saw a lot of 12s. That was very good. So you had 6, absolute value, 2x plus 3 equals 12. And then there was some confusion over what to do with this 6 here. We had to get rid of it. And right now it's multiplying. So we're going to divide by 6, and that will eliminate it. So I have absolute value 2x plus 3 equals 2. Once you have your absolute value all by itself, the next thing you want to do is split it into 2 equations. One's going to be equals 2. The other's going to be equals what number? It's negative 2. Good. So one is, notice I dropped the absolute value at this point because I'm just talking about the insides. The insides could be positive 2 or the insides could be negative 2. All right, and then to solve for x, I saw a lot of you subtract 3 and then divide by 2, and we don't get integers, but in life, our answers are not always integers. That's okay. You can leave that as negative 1/2 or negative 0.5. They're both fine. So I got negative 0.5 and negative 2.5. All right. Once you feel confident about that page, you can turn the page. We're going to do inequalities on the back. So instead of an equal sign, we've got a less than or a greater than. It does add just another level of complexity to your problem here. Does anybody need a minute here before I turn it? Okay. All right, I don't like this example too much, so I'm going to skip the example and work through some other problems with you. I'm going to work through 7 and 8 and then let you guys work through 5 and 6. But before I work through 7 and 8, let's look at the steps at the top. Okay, step 1 says isolate the absolute value. That's the same, right? Nick, is that the same as the other page?
What?
Isolate the absolute value?
Yes.
Yeah, we did that. Write as 2 separate equations. They're actually called inequalities when you have the less than or greater than sign, but I won't be picky. So you're going to write it twice. Notice what changed. Not only did we have negative 4 and 4, but also our greater than changed to a what? Less than. So when you change to something's opposite, you also are going to change your inequality. So greater would be less would be greater. Solve for x and then check to make sure your answers make sense. We graph these numbers on the number line just to help us make sense of what our answers are. In this case, if I got an answer, for example, like x is greater than 5, I want you to remember that that's a lot of numbers. What's a number greater than 5? 6, 7, 6 and 7, what else? 20?
5.1.
5.1. Yeah. So there are a lot of numbers greater than 5. So we're going to get answers that are going to be representative of like a whole interval of answers, a lot of answers. We're going to do not 5 and 6 first. We're going to do 7 and 8, and then I'll let you go back and do 5 and 6. Okay? So let's go to 7.
Oh, we're not doing that.
You're going to go back to them. So if you already started, you're good. All right, number 7. Is the absolute value isolated yet? We have to get rid of what number? 2. Talk to your neighbor about how you're going to get rid of that 2. Okay, I heard a lot of divide. That's good. Does anybody have a good way of remembering which one is less than and which one's greater than? Yes.
I was in like third grade, that if something's like greater than, it's
Uh-huh.
an alligator and it wants to eat that number that's, I guess, behind it or in front of it.
So the bigger part is on the bigger number. So like the alligator's actually eating the bigger one?
Yeah.
Yeah.
That's what I meant.
Okay, good. All right. Did anybody else hear what Layla heard about the alligators like eating the bigger number? Remember that from elementary school? Anybody have a different way of remembering it? For me, I just remember that the less than kind of looks like an L, right? The less than looks like an L, and then the greater than doesn't really look like an L, it's backwards. Less than is L. So anyway, this says x minus 4 is less than or equal to 5. We're going to write it two ways. So we're going to have x minus 4, bless you, less than or equal to 5. That's exactly what we had before. We just dropped the absolute value. The other one, x minus 4, the less than or equal to changes to what? Greater or equal to, and the 5 changes to -5. Now, there's an extra step in here too. I'm going to try to talk to you real quick about why there's an extra step. So, when you're solving and you have your absolute value by itself, this here is a less than. Instead of saying less than, we say less than. And the reason we say it weird like that is because that reminds us that it's going to be the word and in between the two. So it's this and this. And. So when you solve your absolute value and you have less, instead of saying less than, think to yourself less than, and that reminds you that you need that word and in between. Now I can solve them. X is less than or equal to 9 and this one. X is greater than or equal to -1. You can make a number line down here. If you want to write all the lines in between, you can, or you could just put -1, like that. All right, so when it says and, that means it's both. It has to be both less than 9 and greater than -1. So it makes that line in between. And then I want you to know that another way to write this is like this. And this literally just means x is between 1 and 9. Why did I color in the dots at the end? I have one hand. Anybody else? I think some people know, they just don't want to raise their hand. 2 hands. 3 hands. Nick, what were you going to say? Greater than or equal to. Anybody else think it's because of the greater than or equal to part? Yeah, so if it didn't have equal on it, you would do an open dot. So if you look at these, you see that the next one doesn't have equal on it, so that one's going to have open dots. All right, in number 8, is the absolute value isolated? Number 8. Yes, the absolute value is isolated. There is nothing else on the left side of the inequality. It's isolated. That means we can write it twice right now. So I'm going to write 2 minus half x greater than 5. 2 minus half x less than -5. Do you notice how this is a greater instead of a less than? So I'm not going to say less than. Instead of and, what word might I put? Or. It is or. And the memory device for that is to think of great or. Great or, less than. It just helps you remember which one's an and which one's an or. Solving this is a little bit tricky. How do I get rid of the positive 2? Yeah, you're right. So we do subtract 2. Why are people tricked into thinking we add 2? Because of the minus after it, right? This minus belongs to the half. So, so we have to subtract the 2. And then that minus, remember, it belongs to the half. So bring it down with a half. So I have negative 1/2 x is greater than 3. How could I get rid of that negative 1/2? So I heard divide. I could divide by negative 1/2, right? Like before I divided by positive 1/2. What's the other way? Times, and I would actually multiply by negative 2 to get rid of this 1/2 here. So you could multiply by negative 2 on both sides, or you could divide by negative 1/2. Remember, negative 1/2 is also negative 0.5. So if you really don't like fractions, you could just divide by negative 0.5 on both sides. So use your fancy calculator to do that. And what is 3 divided by negative 0.5? Hey, I want to look at the calculator with you because I realize that the negative sign is different, right? When you do 3 divided by negative 0.5, you can't use the minus sign for the negative. You have to use the negative that's down here. And the negative comes before the 0.5. That's different from your phone calculators, like that. So you type 3 divided, then use the negative down here, and then 0.5. What number do we get? Negative 6. Who remembers when you divide both sides by a negative number, what happens to my greater than sign? It does flip. Does anybody remember that from elementary school, maybe middle school? When you divide both sides of an inequality by a negative number, that inequality flips. All right, so my greater than is now a less than. And that's because both sides were divided by a negative number. All right, I'm going to do this side. The steps are the same. There's just like a lot of tricky steps to this one. Yeah. So when you divide by a negative on both sides, it does switch what's happening there. I'm going to see if I can find the sticky note to give you guys a little note on that. I want to think about a simpler situation. If I have something like x is greater than 5, oops, went away, down here. And I want to multiply, so x is greater than 5 is over here. And I want to multiply both sides by negative 1. So I'd have negative 1x and negative 5. Like that. Sorry, I was trying to think of how I was going to do that. It does flip it, because once you come to the values over here that are opposites, like 5, 6, 7, 8, right? 5, 6, 7, 8 are solutions over here. When you take their negatives over here, negative, here's negative 5. Negative 5, negative 6, negative 7, negative 8. I just want you to notice that those numbers are less than. So when you have numbers that are greater than 5, like 5, 6, 7, 8, 9, 10, and you take their opposites are actually on this side, which is less than. It's a little tricky to explain. It's a little tricky to understand. What's that? Say it again.
Does that apply to?
Yes. Good question. So Nick said, does that also apply to greater than or equal to? Yes. But it's only when you divide both sides by a negative. So like you can have a negative number on top and divide. That's not a problem. But when you divide both sides by a negative, then you're going to switch. All right. Great or, so we're going to put an or in between here. There is no way to combine that into one statement when you have an or. So that's your final answer there. But we are going to graph it. And we said it's going to be an open dot because it doesn't have equal to on it. All right, so I saw a lot of good work with this one. I saw 2x minus 3 is less than 7. And then I also saw 2x minus 3 is greater than negative 7, right? And is this one an and or an or? It's and because, and not because, but the way I know is because it's a less than sign. So when I see a less than sign, I think less than. Okay, so that helps me know it's and. Okay. All right, and then I'm going to solve. So I'm going to add the 3. 2x is less than 10. Divide the 2. So I get x is less than 5 for a part of it. Add the 3. And divide the 2. And why do I not flip it when I divide this time? Yeah, we're not dividing by a negative on both sides. This number is okay if it's negative. And then put the word and in between. So Sydney did something interesting. Sydney wrote this one first, and nobody ever seems to do that. But one advantage of Sydney's method is that when you do your number line, the less than negative 2 is the first thing you draw, right? Because it's on the left side. So if you wanted to take up that practice and also do the negative one first, it might just help you make more sense with your number line. It's up to you. All right, so negative 2, of course, would be on the left. 5 would be on the right. They're going to be open dots because there's no equal sign. And then I need both less than 5 and greater than negative 2. So it's going to be in between them. What questions do you have? Yes, Layla.
Can I ask why when you have the, like, it makes sense, but I don't, like, no, it makes sense.
Okay.
My brain just having
Yeah, sometimes for me too, it takes time to process things. All right, next one is a great or. It's a greater sign, so we're going to remember to put in or. Great or. It is greater than or equal to. A lot of you noticed that, but it's the greater or less than part that helps you know if it's and or. So this is an or. So 3x minus 2 greater or equal to 8. 3x minus 2 less than or equal to negative 8, and an or in between. So you can leave that as 10/3. 10/3 is a beautiful number because it's exact. But when you're making a number line, some people have a hard time locating 10/3. So if you want to round it to 3.3, that's okay too. All right, so I added 2. I'm going to divide by 3. This one works nicer. I get x is less than or equal to negative 2. And there's an or in between them. All right, are you guys getting the same numbers as me so far? Okay. So then I make my number line. I've got a negative 2 on the left, and I've got a 3.3 on the right. So it could either be greater than 3.3 or less than, oh, why did I put an equal to sign? Oh, because it has an equal to sign. How did I drop that? Less than or equal to negative 2.